Okay, today we're going to start our Unit 1 conversation talking about how to classify rational numbers. But first, we probably need to understand what a rational number is. Now, if you remember way back in March in 6th grade, you learned what a rational number was. A rational number is, a rational number is a number, any number that can be written as A over B, where A and B are integers and B does not equal 0. So what this means is a rational number is any kind of a number that we can convert into a fraction with A, the numerator, being one number, and B, the denominator, being the second number, and B can never equal 0. So you got to remember that. We can't divide a number into 0 groups. It's just not defined, so there's nothing we can do. So any number that you get, including a decimal number, you can if you can convert it into a fraction in the form A over B, so a number A over a number B, that means that that is a rational number. So let's look at a few examples of rational numbers and let's see if we can convert them into the form A over B. So if we look here, we see that we have 3 2/5. This is what's called a mixed number, a mixed number. Okay, so what we're going to do is we're going to convert this mixed number to a fraction. And that means my numerator is going to be bigger than my denominator. Now, hopefully you guys remember how to do this. And we call this the popcorn method. And some students use the check method. And I'll show you both ways. So for instance, for the check method, we take a check mark like this, and we separate our numbers. And what we do is we're going to take the 5, we're going to take the 5 and multiply it times the number in front. So we're going to say 5 times 3, and then we're going to add whatever that equals to 2, and that's going to give us our new numerator. So for example, if we look over here, we have 3 times 5 is 15, and then 15 plus 2 is 17. So that's how we got the answer 17 over 5. So that means this mixed number represents a rational number because we can take this mixed number and convert it to a traditional fraction. So let's look at the next one. So if we have 6/10, we can change that to 6 over 10 because we know 0.6 is 6/10. So tenths has to be on the bottom. So again, we have a decimal and we can convert it to a fraction form. So that means that's a rational number. So decimals can be converted to fractions, and that means decimals are rational numbers. So now let's look at the whole number 34 right here. 34 can be written as a fraction. All we do when we have whole numbers is we make the denominator equal to 1. So if you look here, what we do is we take the whole number 34 and we place it above the number 1 in the fraction. Any number divided by itself equals that whole number. So we just convert a whole number to a fraction by just placing it over a denominator of 1. Okay, now how about -7? So when we look at -7, that's actually an integer because it's a negative whole number. So how do we make that into a fraction? Well, we have to keep the negative sign, But just like we did with the number 34, all we have to do is put it over 1, and then that makes we put it over 1, and that makes our integer in the form of a fraction, which is the definition of a rational number. Okay, so that was just a brief review from last year. So let's talk about what rational numbers can look like. Okay, rational numbers can look like positive and negative fractions. So if we have a fraction, it can be both positive or it can be negative, and that it would be a rational number. If we have decimals, positive and negative decimals, as long as we can write it in the form A over B, we have to take some number A and put it over some number B. As long as we can do that, we know we have a rational number. So that means positive and negative fractions and positive and negative decimals can be written in this form. So that means they are rational numbers. Now remember integers. These are our positive and negative whole numbers. So up here, these were considered 34 and -7. Those were considered integers. Okay, because they're both whole numbers, and this one's positive and this one's negative. So these are considered integers. And we know that integers can be written as fractions, so integers are rational numbers. And then when we have whole numbers, we know that we can take a whole number and just put it over the number 1, make the denominator 1. Remember, in both of these cases, we made the denominator equal to 1, and that converts it to a fraction in this form right here, and that's a rational number, okay? So rational numbers are going to look like positive and negative fractions. They're going to look like positive and negative decimals. They're going to look like integers, which are positive and negative whole numbers, and then whole numbers are just the positive counting numbers, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? All of these types of numbers belong to the entire system called the rational number system. Okay, the rational number system is a large set of numbers. So inside that large set of numbers called the rational numbers are these smaller sets of numbers, and those smaller sets are known as subsets. So if we look at the traditional Venn diagram that shows us the rational number system, we can see that we have the rational number systems, the rational numbers, so everything that looks like a fraction or a decimal or a positive or negative number, all the biggest set is called the rational numbers. So if you look here, -4.577, excuse me, -45.777777. This is repeating, the 7 repeats. So this is a negative repeating decimal, so that belongs in the bigger group called the rational numbers. For instance, we have this fraction, 12 over 73. That's a fraction in the form A over B, 12 over 73. So that is a rational number. Okay. Now within that larger group, there is a smaller subset. Now remember, we start with the largest group on the outside, and then we get more precise with the type of numbers in the next set. So these sets that are inside the bigger group, they're actually more specific, and they have very, very precise characteristics. So in this case, you should remember the integers go inside the rational numbers, and integers are all the positive and negative whole numbers. Okay, so if we have +1, That would be an integer. That would be a whole number. And a negative whole number would be in the integers. Okay. Within that group, we go down to the whole numbers. And the whole numbers are going to be our counting numbers, but these are all positive. Whole numbers are always positive numbers. And I can't write with my cursor, so I'm just going to put POS for positive. So whole numbers are always positive. If you have a negative whole number, then you know it goes into integers because that's a larger group, because that includes all negatives and positives. When we go inside, this group gets smaller and we're only talking about positive numbers. Okay, so let's look at some definitions. And I'm going to try to use something here. Okay, so when we look at the subset, excuse me, when we look at the set of rational numbers, okay, we have natural numbers, we have whole numbers, integers, and rational numbers. Now, we didn't talk about natural numbers in this Venn diagram back here, okay, but the natural numbers are actually inside the whole numbers, and we'll talk about that in a second. Okay, so let's look at this real quick, okay, and the natural numbers is the set of natural numbers are the set of all positive, see if I can do this, positive integers. Positive integers. Examples of that would be like the number 1, the number 2, the number 3, and the number 4, and so on. Okay? And then when we get to whole numbers, whole numbers is the set of all positive counting numbers starting with 0. So if we were going to do a list of the positive counting numbers, we would say 0. And then we go 1, 2, 3. So those are the whole numbers. Whole numbers are all the positive counting numbers. It does include 0 at this point, but 0 is special. It doesn't have any value. It just holds a place. Then inside whole numbers, or I'm sorry, then the group above that is called integers. And integers is the set of whole numbers and their opposites. Okay, so example of integers would be something like this. It would be, let's say, we have the whole number 5, and the opposite of 5 would be negative 5. So those would be a pair of integers. What if I had negative 200? The opposite of that would be positive 200. So those would be some examples of integers. Integers is the set of whole numbers and their opposites. And then we have the larger group of rational numbers. And rational numbers are numbers, if you remember from the first page, numbers that can be written as fractions. And when we write them as fractions and we do the long division and we calculate and convert to decimals, then they have to have terminating decimals, and they can also be repeating decimals. So some examples of that would be, okay, we're talking about, remember, rational numbers can be both positive and negative. So examples would be something like negative 5.6. That would be a rational number. It's a decimal and it's negative. It's not a whole number. It's not a natural number. And it's definitely not an integer, because remember, integers are just the opposites of the whole numbers. So it has to go into the larger group, which is rational numbers. So another example would be, let's actually look at a fraction. We have 3/4. So we have a fraction, and we know that fractions belong to the rational numbers. Okay, a fraction is not a whole number, so it's not going to fall under this category or this category. So that means it's got to be in the larger group of rational numbers. And then we have what is called mixed numbers. We converted this as one of these a minute ago. So if we have a mixed number, say for instance 3 and 1/6, we know that we can convert this. We say 6 times 3 is 18 plus 1 would be 19. So that's 19/6. So that equals 19/6. So there's my fraction. So I know that I can categorize that as a rational number. Okay, so remember, if it has any kind of a fraction in it, or it just looks like a fraction, then it's going to go into the rational numbers category. And these can be positive and negative. And then you have negative 5.6, so you have a decimal format number, and it can be positive or negative, and that means it's a rational number. Okay, so let's go down a little bit further. So let's do an example. Let's label this. Now up here we talked about natural numbers. So that's the set of all the positive integers. So I'm going to show you where that goes in the diagram, because you'll need to know this for the STAR test. Okay, so we're going to label the parts of the number system diagram below. Now, one way to remember this is to use this hint down here. Ride in with Navasota. Okay, now what that means is you start with the letter R, and then the letter I, then the letter W, and then the letter N. And we're going to start from the biggest group first. So that means we're going to come out here, and then this is going to be R for ride. So that's the biggest group on the outside. Then we're going to come inside towards the middle, and we're going to say I. So ride in, and then we come to the next subset, and that's going to be W. So that's where the W comes in here. And then the natural numbers actually go right here. So that's how you remember this diagram. So we have ride in with Navasota, and that's how you remember it. And R stands for rational. So that's the rational numbers. And then I stands for, sorry about this, this is hard to do, integers. W stands for whole. And then N stands for natural. Okay, so that's how you need to remember how to label your diagram. So it's ride, start on the outside with the biggest set first and work inwards. So it's ride in with Navasota. Okay, so you have to keep track of these labels, because you might get some diagrams and be asked to identify them. So let's look at this one quickly. So for example, use the graphic organizer below to correctly place each of the following values. Okay, so we know rationals. Rational numbers includes fractions and decimals. So let's come up here and let's find everything that looks like a fraction or a decimal. So we have 1/8. So I'm going to go ahead and cross that off, and I'm going to put that, I'm going to put that here because it's a rational number. So it belongs in this group on the outside, rational numbers. And then let's look here. Now remember, fractions can be negative too. So if it looks like a fraction, we're going to throw that into the rational category. And here's another fraction, 2/3. So then we can put that in the rational category too. Okay, so let's look at what's left. Let's look at -9. -9 is a whole number. So does it go here in whole numbers or does it go here in integers? Now remember, whole numbers are just positive. Integers are positive and negative. So we have a negative whole number up here. Let me change the ink. We have a negative whole number up here. So what we need to do is put that in integers. So -9. Oops, sorry about that. Okay, so let's erase a little bit. Okay, now we have 15. Well, 15 is a positive number and it's a whole number, and we know that positive whole numbers have to go under whole number. So we got rid of that. Okay, how about -37? -37, well, 37 is a whole number, but because of the negative sign, that's going to put it into integers, because remember, whole numbers are positive and negative, excuse me, positive only, but integers can be negative. So that means -37 is an integer. So we'll cross that off. So how about 126? Well, that's a positive whole number, so that's going to go here. 126. All right, now what about 0? Okay, if we go back to our page back here, if you remember, your whole numbers are not part of the natural set, but they are part of the what? The whole number group, because remember, it's the set of all positive counting numbers starting with 0. So 0 belongs with the whole numbers. Okay, so now let's look at the next one again. So now we have a set of numbers that have been classified below. Determine which numbers are in the incorrect location and justify your response below. Okay, so we look at the group. Now remember, ride in with Navasota. Okay, so we've got it in order correctly. So let's look at these numbers over here. So let's look at -1.0. So -1. They have that in the whole number category. Is that a whole number? Remember, whole numbers have to be positive. So this cannot be a whole number because it's negative. Okay, so -1 is actually what? It's actually an integer. Okay, so now let's look at 10/5. Now, whenever you have a fraction, you want to check to make sure if you can convert this to a whole number. So 10/5, remember, fractions are little mini division problems. So we're going to take 10/5, that equals 2. So what is 2? is 2, let's find it. Let's find 10 over 5. Where do they have it? They have it as a natural number down here. Is 2 a natural number? Yes, it would be a natural number. So it's in the correct place. So we're just going to put a check mark here because this one's correct. Okay, how about -7? -7 is a negative whole number. So it can't go here because it's negative, but it has to go to integers because integers are positive and negative whole numbers. So -7 is in the correct place. So we'll put a check mark there. How about -8.5? Now remember, if you have a fraction or a decimal, we know we're not talking about whole numbers, so it has to be a rational number. So is -8.5, do they have it in the right category? They have it as an integer, but it can't be an integer. It's got to be a rational number. So this one is not correct. And it needs to be a rational number. Okay, it's not correct. They don't have it in the right place. They have it as an integer, but it's supposed to be a rational number. Okay, how about -9/7? Again, we have a decimal and it's negative. So any decimal is going to go into rational. So -9/7 is right here. So this is in the correct spot. Okay, now let's look at 3/6. Now remember, you want to try to divide this out if you can. 3/6 really equals 1/2. So 1/2, that's a fraction. So we know it has to belong in the rationals because it's not a whole number. So is 3/6 classified as a rational? Yep, it's in the rational section, so that's good. How about 3/4? Well, that's a fraction. So we know anything that's a fraction and anything that looks like a decimal, so a positive and negative fraction or a positive and negative decimal, we know that that belongs in the rational category. So does 3/4, is that labeled correctly? 3/4 is in the rational section. So this one is okay. Now, be careful with this one. We have a negative number and we have 8/2. So go ahead and see if you can do the division. Little mini division problem. 8 divided by 2 is 4. And it's negative. 4 is a whole number, but it's negative. So whole numbers are positive. Integers are positive and negative whole numbers. So -8/2 has to be a integer, and they have it listed as rational, so that's incorrect. And this should be listed as an integer. Okay, now that's it for today. What you need to do is you need to go in and you need to do your assignment in Google Classroom. And I apologize for the length of this. I'm learning how to do this writing, so it's a little longer than necessary, but I'll get better at it as we go.